Okay, so we're going back through 6.1, example 6, page 304, and we have to go back and get all the data from examples 1 and 2, which is kind of a pain. I'm sorry about that. So in example 6, it wants us to do, it says the researcher from example 1 wants to estimate the mean number of hours spent on required athletic activities by all student athletes in the conference. How many student athletes must be included in the sample to be 95% confident that the sample mean is within 0.5 hours of the population mean? So minimum sample size, we have this formula here on the formulas page that is from chapter 5 and 6, again in the weeks 11 and 12 modules. You can find that. I would print that out. We have this formula for Z sub C, critical value of Z, depending on our level of confidence, times sigma, the standard deviation, over the margin of error, which will be given. It might say you want to be within or how close you want to be. They don't always call it the error, but it'll say how close you want your estimate to be. You square it, and then you round up that answer to the next whole number, so I'll explain that. So if we go to example 6, it says we want to be 95% confident. So our critical value of Z is going to be 1.96. Again, from the formulas page or the bottom of the negative side of the Z table for a 95% confidence, 1.96 is our critical value of Z. Times sigma. We have to go back to example 2, I believe it is, to find sigma, which is 2.3, the standard deviation, divided by our new margin of error, 0.5, and then squared. So before we do this calculation, let me pull back example 2. In example 2, when we had a 95% confidence level here with the sample size of 40, back from example 1, and a margin of error, sample size of 40, 95% confidence, and a standard deviation of 2.3. Remember, our margin of error turned out to be 0.7. Well, now when we go to example 6, we still have 95% confidence. We still have the same standard deviation, but now we want a smaller margin of error. We want less error in our estimate. So if we want a more precise estimate with less error than we originally calculated with that sample size of 40, which had a margin of error of 0.7, if we want a smaller margin of error, we're going to need a bigger sample than 40 to get a more precise estimate. So when we put in these numbers, critical value of Z 1.96 times sigma, the standard deviation of 2.3, divided by the margin of error E 0.5, that's going to give you 9.016 when you do this part. Leave all that in your calculator and hit x squared. Square it. Remember back from chapter 2 when we were doing standard deviation, we used the x squared key to square things. Square that, and that's going to give you 81.28 something. Now, we always round up this answer to the next whole number. So 81 students in our sample is not enough. So we don't round down because 81 is not enough. We need about 0.3 students. You can't have 0.3 students, so 81 is not enough. We have to have a sample of size 82 to have the same level of confidence we had in example 2, the same standard deviation, but less error, a more precise estimate. We're going to need a much bigger sample than 40. Now we need 82 in our sample. So that's it from section 6.1.